So today we will be working on these objectives. Drawing a line of best fit by eye, using the line of best fit to make predictions and determine reliability, and then using technology. So if you haven't yet, try the warm-up, work on the warm-up, and just as a reminder, make sure you get the IB exam registration form filled out, turned in. So at this point, try the warm-up. If you haven't yet, pause the video, and then come back and watch for the answer key. So just remember to calculate R. That would be something you need to make sure you can do with your calculator. So calculating R, you need to type in your data to L1, L2, and then you need to go stat, calc, linear regression, which is option number 4. And then type in your 2 lists and then hit enter, and you should see a list of things that pop up. That's A, B, R squared, and R. R is the one you want. And if you did that correctly, you should get 0.9173, so on, so on, so on. So the 3 sig figs, 0.917. Just remember when we comment on the value of R, we want to know the strength and direction. So 0.917 is really close to +1. So whether it's +1 or -1, that is a strong correlation. And then it's positive, so that means it has a positive direction. So moderate, strong, I would lean towards strong in this case. If you said moderately strong, that would be probably okay. And then positive. Okay. Calculate the mean points. In order to do this, you still have your data in L1 and L2. Just do one variable stats for each list. One variable stats to find the mean of the L1, one variable stats to find the mean of L2, and then just plot those or write that down as an ordered pair. And if you do that correctly, 15, 29. So 15 is the average age, 29 is the average distance thrown. You can see on my graph it popped up that I now have the mean point plotted and the line of best fit. And it goes through the mean point, and that is important. Okay? Otherwise, the line needs to go through as many of the other data points as we can with approximately equal amounts above and below that line. It needs to accurately reflect the trend of the data. So now, using that line, we're going to make a couple estimations. So for a 14-year-old, I would go to 14, travel up, travel over, and I would estimate that to be about 25 meters that they could throw according to our line of best fit. Okay? So notice that 14 was not a data value that I had in this data set. It was using my graph, my line of best fit, to go up and travel over, kind of like cumulative frequency. Same for 22, except notice 22 is off the mark. I'm still going to try to estimate that as best as I can. I'm going to say that's about 20 or 52 years old. Sorry, approximately 52 meters is what a 22-year-old could throw, according to my line of best fit. So now, which of those 2 estimates is likely more accurate and why? So other than the fact, I'm going to say ignore the fact that 22 does not fit on my graph, or it's not on my graph. If I had an extended graph and I actually had 22 on that where I could easily mark it, I still want to know which one of these is more accurate. And that's part of what the first chunk of notes is. So we're going to move along into those notes real quick and cover some definitions. And those definitions are the difference between interpolation versus extrapolation. So if you notice in that data set for that graph, we have 2 poles, the lower pole and the upper pole. And those are just simply the lower and higher data points on in my data. If we are making an estimation that is between the poles, that's interpolation. If we are making an estimation or predicting for a value outside the poles, that is extrapolation. There's some issues with both of them, right? So the accuracy of interpolation depends on how linear the original data was. So that is directly connected to the correlation coefficient, R. Okay? So how linear, what's the value of R? For extrapolation, a couple of things. Not only does it depend on how linear the original data was, but it also assumes that the linear trend will continue. That's a pretty big assumption, right? So think, especially for this graph, what this data represents, and that is the age and the distance that someone can throw. So think about if this trend, we're assuming if this trend continues, then if we just continue this on and on and on and on and on in a linear way, that's going to be crazy. Because think about your 90-year-old grandpa or grandma. According to that trend, if they're 90, then they can throw like 120 meters, and that's ridiculous. So likely at some point, this trend is going to trail off, and it's no longer going to be linear. So if we start estimating things like for a 22-year-old that is outside this data set, I don't know. It might be accurate in this case, but maybe not. Okay, so that's where the extrapolation, we have to be very careful. And that really comes down to what the data is representing. So in the next video, you will be working on these objectives with the rest of the notes.